Alright, the time you've all been waiting for, absolute value equations and inequalities. So we're going to talk about how to solve absolute value equations and absolute value inequalities in this section. Um, we're going to first look at three basic cases. So if you have the absolute value of some expression equal to some number, what that means is that expression, this x that's inside of the absolute value, is either equal to that number or it's equal to the opposite of that number. So on a number line, if you just had x, you would have two solutions, right? And so we'd have a solution at k. I'm going to use dots here. And negative k. So negative k and k. So your solution set would be the opposite of k and k. So I'm usually using these brace symbols as a solution set, just like we did with equations before. Now, the two trickier cases are where you have absolute value less than a number or absolute value greater than a number. Okay. If you have the absolute value less than k, where k, and these work if k is a positive number. Okay, if k were negative, we'd have problems, right? You can't have the absolute value equal to a negative. And so all these cases only work if k is greater than 0. Okay? So that's something to keep in mind. If k is less than 0, or if k is equal to 0, there are some other things that happen, and we'll have to take those case by case. We'll have some examples of that a little bit later. If the absolute value of x is less than k, then we could actually write that as a double inequality as negative k is less than x, which is less than k. Alright? And we know what that graph would look like. It would be everything between negative k and k, right? And I'm going to use my little highlighter again here. And we shade everything in between. So if you have an absolute value that's less than a number, then we can put that expression x in the middle and write it as a double inequality with the opposite of k on one side and k on opposite of k on the left and k on the right. If we have the absolute value of x is greater than k, then something else happens. We can write this as a compound inequality, where x is less than negative k, or x is greater than k. And if we remember from the last section how we graphed that, x is less than negative k would look like this, right? With everything to the left and this with everything to the right. I'll use my little highlighter to shade that. So we have all that stuff and all this stuff, right? So, and then the solution set, we could use interval notation here. This would be what? Negative k comma k. In interval notation, this would be negative infinity to negative k. We have an or, so this is a union of k to infinity. All right, so these are kind of the three cases we're going to look at. Again, these cases only work if k is a positive number. So keep that in mind. Right about now, I usually get some people ask the question, what if we have less than or equal to, or greater than or equal to? Well, the properties would still hold. We would just have a less than or equal to here instead of less than, or we'd have a less than or equal to and a greater than or equal to here instead of less than and greater than. And instead of parentheses here, we would have brackets, right? Now, there is another thing that could happen. You could have the absolute value of one expression. So if a is an expression, and we have the absolute value of that expression equal to the absolute value of another expression b, then what this would do, if we have two expressions, both in absolute value set equal to each other, we can write an equivalent form of either a equals b or A equals the opposite of B. All right. So if you have two absolute values in an equation, we can write it as A equals B and ignore the absolute value, or A equals negative B, and the or means we have the union symbol, right? And so these both end up being part of your solution. Okay, so we'll do some practical or some examples, and you can see how we can apply these cases. First example, we have the absolute value of this expression is equal to 7. So that's similar to case number 1, right? It's important that we isolate the absolute value, make sure the absolute value is by itself on one side before we start manipulating it. And that is the case here, right? We have the absolute value by itself. We don't have anything else with the absolute value. So we don't have just an x here, so we can't say the answer is 7 and negative 7. We have an expression. But that expression then would be equal to 7, or that expression would be equal to negative 7. So when we rewrite this into its equivalent form, we're going to say 9 minus 4x, which is our expression in the absolute value, is equal to 7, or 9 minus 4x is equal to negative 7. Now we can solve both these equations to get all our solutions. So here I'm going to subtract the 9, right? And then we get negative 4x is equal to negative 2. If we divide by negative 4, or I'm going to multiply by negative 1/4. These go away. We get x is equal to a negative 2 times negative 1/4 is just positive 1/2. Okay, so that's one solution. The other part gives us probably another solution. Most absolute value equations will have two solutions. Some of them may only have one, and some of them may have none, but most of them will have two. Okay. We're going to subtract 9 from both sides here. Here we get negative 4x is equal to negative 16. And again, we multiply by negative 1/4 or divide by negative 4, either one. Maybe this time I'll divide by negative 4. We get x is equal to 4. So here we have two solutions. We could always plug them back in to make sure they work. When you present your solutions in my lab, we want to write a solution set. So our solution set includes both of these numbers, 1/2 and 4. Again, we could check them both, so this would be, I'm going to put a box around my solution set here. If I check them, 9 minus 4 times 4 is 16. 9 minus 16 is negative 7, but when you take the absolute value, it gives you the 7. 9 minus 2, because 1/2 times 4 is 2, would be 7. The absolute value of 7 is also 7. So we're in good shape. Absolute value tells us the distance we are from 0. And so that's why it can never be negative, because negative can't give you a distance, right? Can't have a negative distance. All right, let's look at the next one. This is from this little property here. If we have two expressions equal to each other with an absolute value, we can write one expression equals the other, and we can write one expression equals the opposite of the other. So for this guy, when we split it into two equations, we have 3x plus 2 equals x minus 5. We can ignore the absolute value, but there's another possibility. We could write 3x plus 2 equals the opposite of the other expression. So opposite means negative, the whole expression, right? So we need to solve these two equations to get all of our solutions. Here I'm going to get all my x's together. I'll subtract x from both sides. And I'll get all my numbers on the other side, so I'll go ahead and subtract 2 from both sides. And then I get what 2x is equal to negative 5 minus 2 is negative 7, right? Divide by 2, I get x is negative 7/2. Over here, I'm going to distribute the minus sign. I get 3x plus 2 equals negative x plus 5. Then I can get all my x's together. I'm going to add x to both sides. And I'll go ahead and subtract the 2 from both sides. So here I would get what 4x is equal to 5 minus 2 is 3. So divide by 4, we get x is 3/4. So we have our two solutions again, and again we could plug them both in to make sure they work. We have our solution set though with -7/2 and 3/4. And those are my two solutions here. So those are a couple of fairly typical absolute value equation problems that we could solve. And we'll look at some more on the next page too. But now we're going to move to absolute value inequalities. If we follow the cases, we should be fine. So if we look at part A and number 2, we want to solve, oh, by the way, we're not asked to graph on this page, but you could graph these if you wanted to. But solve each equation or inequality. Absolute value of 4x minus 6 is less than 10. Which case does this fit up here? Well, it's case 2 where we have the less than, right? One question to always ask is this thing a positive number? If it is, we can follow this case. If it's not, we have to do a little bit of thinking, okay? But this is positive, so we can follow this case. We can rewrite this as a double inequality. So we take this item in absolute value and put it in the middle, and we put the less than signs on both sides. We have a 10 over here and a -10 over here. And we solve the double inequality. We try to get x by itself in the middle. I'm going to add 6 to all three parts here. We get a -4 is less than 4x, which is less than 16. I could divide all three parts by 4. That will give me a -1 is less than x, which is less than 4, right? Just divide them all by 4. Interval notation. This is pretty easy to do now, right? We have -1, 4. Since we have less than signs in both places, we use parentheses. That would be our answer. And of course, you could graph that if you wanted to. We're not asked to here, so I'm not going to do that. I assume you probably already know how to do that. So if you are asked on my lab to graph this, it wouldn't be terribly hard, right? All right, let's look at the next one. Looks the same except we have a greater than 10. 10 is a positive number. We can use this third case, right? We're going to split it into two inequalities with an or in the middle, a compound inequality, right? So we could have 4x minus 6 is greater than, or is less than -10. So we have the expression is less than the opposite of that number. Or 4x minus 6 is greater than 10. So part of this inequality basically ignores the absolute value sign right here, but the other part gives us some other solutions. We make the less than and use the opposite of that guy. All right, so let's solve this. We're going to solve both separately. We're going to add 6. We get 4x is less than -4. If we divide by 4, we get x is less than -1. On the other one, we're going to add 6, right? So 4x is greater than 16. Divide by 4, we get x is greater than 4. Okay? So, and we have the or in between. So we have this set or that set. And if you remember how we translate that all to interval notation, x is less than -1 is everything from -infinity to -1, or becomes the union symbol, right? X is greater than 4 is everything from 4 to infinity. And there's our interval notation. All right. And now we have a couple others down here. Let's see. So for this one, we have the absolute value. Then we have this plus 6. Notice the absolute value is not by itself. Any of these cases up here, the absolute value is by itself. So first thing we have to do is isolate the absolute value before we can even consider the cases. So I need to subtract 6 first. Then we have absolute value of 5 minus 8x it's not 15, we're going to make it a little darker maybe, is greater than or equal to 8. Alright, so now we have absolute value by itself, and we can use case number 3. Again, this is a place where some people say, well, there's no equal to bar here. The same rules follow. We just replace every one of these with an equal to bar underneath, and if we were to graph it, the parentheses become brackets. Alright, so we can use case 3, which means this tells us, and is 8 positive? Yes, 8 is a positive number, so we can use that case. 5 minus 8x is less than or equal to the opposite of 8, or 5 minus 8x is greater than or equal to 8. So similar to what we did in part B, but we had to isolate the absolute value first. Okay, so let's see. What do we do now? I'm going to solve both of these separately, right? So I'm going to subtract a 5 from both sides here. I get negative 8x is less than or equal to negative 13. So that if we divide by negative 8, that means x is less than or equal to 13/8. Okay. We have our or. Solve this one. Subtract 5. This is a little easier because these are not negative. But so 8 minus 5 is 3, right? So we have negative 8x greater than or equal to 3. Divide by negative 8, and we get x is greater than or equal to negative 3/8. Yeah, I'm doing some of this arithmetic in my head, but hopefully you can follow along by now. Dividing by negative 8 will give us a negative 3/8 here. Alright, so we have this or that. And so let's remember how to write this in interval notation. We're going to use our set symbols. X is less than or equal to 13/8. That's everything from negative infinity to 13/8. I'm going to do this over in the margin. So negative infinity to 13/8. And 13/8, since there's an equal to bar, we're going to use a bracket here. Or gets translated to the union symbol. The other inequality, x is greater than or equal to negative 3/8. So that's everything from negative 3/8 to infinity. We have a bracket with the negative 3/8. Parentheses are always with infinity and negative infinity again. So this would be our solution set for this absolute value inequality. We have one more on this page to look at. Notice we have a 0 here, right? So if we have a 0, it's not positive, but that's okay. We can still solve it. In fact, we could use this case up here. That's an equation, right? So this is, if this is equal to 0, if we split it into two equations, we'd have, well, that expression is equal to 0 or negative 0. But the opposite of 0 or negative 0 is still just 0. So this is the only time you can ignore the absolute value completely and just solve the equation. So if this is equal to 0, we can just write 7x plus 28 equals 0 and solve that equation. It's the only time we can really do that is when you have it set equal to 0. Okay? So I'm going to subtract 28. We get 7x equals negative 28. Divide by 7. We get x equals negative 4, right? And we only have one solution. It's rare for this to happen, but it does happen occasionally. And so your solution set, in this case, is just the number negative 4. It's not an inequality or anything, so we actually have an actual number, single number for our solution. And that would be our answer here. Alright, so that's it for the first page of A3. We'll continue the next page in the next video.